Hello and welcome to the chapter 5 of the KNX advanced course. It was about IP communication. This is provided by me, Amir, and I hope you enjoyed. Okay, what we learn in this chapter is we want to know the conjunction between IP network and KNX network and how they related to each other. So remember that about the IP router and its characteristics to control the traffic of the data. We consider those concepts in another chapter. It was in the couplers. Okay, so now here we only focus on IP and we want to learn something new. First of all, we want to talk about the protocol. IP communication in KNX is also structured according to the OSI reference model. Communication takes place via the application layer here, which generate the KNX net IP telegram, the transport layer UDP, the network layer, and the Ethernet as a physical layer. Remember that here we have 5 layers, but in OSI, in TCP IP, we have 7. Additional information for the respective layer, the header, is always added to the KNX net IP information in similar way as for the TP protocol. But the book provides us some definition to somehow prepare us for the next concepts. First of all, what is HTTP? Is a protocol mainly used to load the web pages like text, image, and multi-data from the World Wide Web. The TCP is located in the transport layer and is used for connection-oriented data transfer. UDP is a user datagram protocol. Like TCP is located in the transport layer. It is minimal connectionless network protocol with the task of assigning data to the correct application. IP is an internet protocol. IP is located in the network layer and thus forms the first layer, which is independent of the transmission medium. Various devices can be classified into logical units, subnets via their IP addresses and subnet masks. Via this classification, it is possible to address devices in a larger network and establish links to them, as logical addressing is the basis for the routing. ICMP, Internet Control Message Protocol, is used for exchange of information and error messages via the Internet Protocol. And ARP is Address Resolution Protocol, is enabled the assignment of network addresses to the hardware addresses. And the last but not the least is Igmp, Internet Group Management Protocol. Is based on an IP protocol and enable group communication via the IP version 4 multicasting. The simultaneous distribution of IP packages via one IP address. Groups can be managed dynamically. Management takes place in the router and switches to which receivers of multicast group are connected. IGMP is mainly needed in a larger network. In this way, it is avoided that the transmission of multicast address leads to a network overload. But we have some example from IGMP in KNX. When ETS in ETS Connection Manager pools for available IP router or IP gateway, this will be done via the KNX multicast IP. Subsequently, all KNX IP devices within reach will reply. The router switch located in between will now bundle all replying devices to a multicast group address. This implies that future multicast transmission will always be routed to the KNX devices only and not anymore to all network devices. So it's going for pools the available IP router and gateway and communicate it. Okay, so addressing of network devices. A network device has at least 2 addresses. One is MAC address, media access control, is linked to the hardware and cannot be modified. It is globally unique. So it means the product when leave the manufacturers, it has its unique MAC address. It consists of 6 bytes with the following format. You can see the IP address Internet Protocol is assigned by the administrator or automatically via the DHCP. In the case of IP version 4, it consists of 4 bytes. IP version 6 currently not used in KNX Net IP and has the format for IP version 4. It is something like 192.168.1.1. The IP address can be compared to the physical address in KNX. It is unique in local network. Remember that the IP address is unique. The physical address of KNX devices is unique. It is entered in the memory of the network device. The MAC address represents a unique serial number. Each KNX device has its own unique serial number. It is the IP address of the hardware and permanent links to it. Yeah. So here we want to compare the KNX devices, twisted pair one, with the IP devices. So KNX device has the physical address, IP devices has the IP address, KNX device has a serial number unique, and IP devices has a MAC address unique. But what is a KNX multicast address? In case of multicast, when the router wants to communicate to the other routers to transmit the telegram, in the case of multicast, a defined MAC address consists of 6 bytes is sent in the network layer as a destination address. This address always starts from 01005E and is then supplemented by so-called 4-byte line multicast IP. In IP version 4, the address range from 224.000 to 239, 255, 255, 255 has been defined for a wide variety of network applications. The multicast IP address 224.0.23.12 is reserved for KNX Net IP. It is possible to change the predefined KNX multicast IP address in the parameter of KNX Net IP devices. In this way, it is possible to establish communication between different from each other separated KNX installation within the same IP network. Please note that all IP router of an installation are listening in on the same multicast address. Okay, so it means if you have several IP router, the multicast address should be the same, okay, because they want to listen to it. And you can see the range of the multicast IP address. Of course, this 224.0.23.12 is reserved for the KNX, but maybe according to the IT man of the building, you should change it, and it is possible to change it. The next concept is the KNX Net IP telegram contains some additional information compared to TP telegram. Okay, when we want to compare the telegram of the in KNX based on IP and TP, we have something more in TP. You can see next slide. I'm going to show you what we have in IP and what we had in the TP. Okay, here the header lengths. This is something that we have more in IP in KNX. The header length is 1 byte. The header size is always the same. It is transmitted nevertheless, as the size may change with the further version of the protocol. It is used to find the start of the total KNX Net IP frame. The header size is indicated in bytes. The next one is protocol version. Okay, so in each telegram packet of data we have the protocol version. It is 1 byte. The protocol version indicates the status of KNX Net IP protocol. It is binary coded and is currently version 1. The next one is service type identifiers, 2 bytes. The KNX Net IP time identifier indicates which action should be carried out. The following table shows defined address, range, and action. Okay, we have the range of the address and the action, tunneling, routing, remote logging, and so on. The next one is total length. It's 2 bytes. The total length of the KNXNet IP frame is indicates in bytes in total length field. The bytes of the previous field, header length, protocol version, service time identifier, are also part of the total length. If the total number of the byte transmitted is greater than 252 bytes, the first total length byte is set to 255. Only in this case, the second byte includes additional length information. And the last one is the KNXNet IP body. Describe the useful data with the KNXNet IP frame. The useful data adopts a different structure depending on the information content which should be sent. It consists of a connection header including the message code 1 byte and the additional length information 1 byte. Furthermore, the IP body contains the so-called CEMI frame. So you can see what we have more in KNXNet IP telegram: header length, protocol version, service time identifier, total length, and KNXNet IP body. Okay, so here twisted pair telegram is compared to KNXNet IP telegram, and you can see what we have more. But of course, in each KNXNet IP telegram, we have the control field, source address, destination address, length of the data, index, length of the useful data, and so on. And check byte. Yeah. Okay. Tunneling. Tunneling is necessary for the connection-oriented transmission of KNX telegram in the IP frame with ETS. This is always the case of a physical address should be addressed as a destination address. It means when programming the physical address or downloading the application program of KNX devices, communication in tunneling is always carried out via the IP address of the KNXNet IP device that is to be tunneled. Address range. The tunneling variant is always used when KNXNet IP device should be addressed directly via the Ethernet. For example, to load the application into a TP device. In this case, there is an address range of 04220H to 042FH in the KNXNet IP type identifier field. 2 addresses are currently defined that you can go for it: tunneling request and tunneling acknowledgement. The tunneling request address is used to send and receive individual KNX telegrams between KNXNet IP client and server. The tunneling acknowledgement address is sent by the KNXNet IP device to confirm the recipient of tunneling request information. Always you can refer to the KNX IP interface and make sure that the tunneling is supported. So here you can see the tunneling example, 2 examples. Example number 1 here. IP gateway in the main backbone line as a universal coupler. Okay, we put it as a KNXNet IP router that provide us the tunneling option, also the point-to-point communication. It's placed as a gateway. In example 2, we put the KNX IP router instead of line coupler, and it is not only the IP router but also provide us the tunneling, okay, options. Okay, about the setting of the interface. If a device in twisted pair line should be programmed by ETS via Ethernet in 2 examples above that I mentioned, the setting of the interface should always be performed at first. You can choose one of the supported KNX communication type: KNXNet IP tunneling, KNXNet IP routing, USB IP. USB and IP routing interfaces are recognized and displayed automatically by the ETS. Okay, so when you connect the USB interface, it automatically find it. When you connected the IP, it is IP interface, it is automatically find it. They do not need to be created. An interface that is not recognized automatically cannot be used by the ETS even if you create it manually. But when you go through it, there is something for setting. I'm going to tell you about the details. The name, enter a user-friendly name for the interface. You can change the name. Host individual address of the host device. Okay, the address in the KNX. Individual address to be selected for the host device. IP interface, IP address found for the interface if recognized resolved. The port, the KNX port is 3671 is by default. The MAC address, the MAC hardware address of the interface as far as can be determined. So how we can find it? For example, if I go here to the ATS6 and run the KNX virtual, from here I can see it's automatically detect the IP interface of KNX virtual. If I can select it, the green tick is coming next to it, and I can change the definitions here. Of course, here we cannot change it because it's provided by virtual, but in reality we can change it. Okay, so here this 127.0.0.1 is the IP address internally of the PC because I use the KNX virtual, and you can see the port and you can see the individual address in a line I select for it. Yeah, great. Always you should aware, and when you do the settings, if you change anything, just click on a test and make the test, make sure, and then select it to the current interfaces, because it's going to be find it as a discovered one, and you should add it to the current one. If several KNX Net IP interfaces are displayed, example different IP routers, if they are functioning as a main backbone couplers, it is now important to select precisely the KNX Net IP devices that is connected to the TP line area of the device to be programmed. So always you should be in a line that you want to program it. Remember that. Okay. If you are in a line 1 from area 1, the individual address should be 11255, for example. Okay. The local individual address must be then correctly set. It is important that the address matches the line or area of the device to be addressed. Moreover, the address shall currently not be used in the installation or project. It is advised that to select 255 as a bus device number, as it probably does not exist in the installation. You should find some device number that is not exist. You cannot be the same address for the interface and some devices. I mean the physical address. A KNX Net IP router of a line 11 thus has the individual address 110 as a coupler address and address 11255 as a local individual address. So remember that when you use the router, you have one host individual address and one individual address. They are different. It's so important. They are different. Okay. If IP router are used as a line or backbone coupler in a KNX installation, they route TP telegram to the primary IP side. If the corresponding group address is entered in the filter table and the parameter is set to filter, the telegram is then sent via the UDP via the multicast address 224.023.12 through the port 3671 defined for KNX. A successful transmission is not confirmed. Data loss on the IP side is, however, relatively unlikely. An IP router that receives a KNX Net IP telegram on its primary IP side via the KNX multicast address will evaluate the KNX Net IP telegram and only route on its secondary TP side if the corresponding group address is entered in the filter table and parameter is set to filter. What's happening is telegram is coming here from this IP router as a backbone coupler. It's going to be multicast through the other IP router as a backbone coupler, area coupler. Okay, so if the destination address is located in the filter table, then it will be router, otherwise it will be blocked. Direct communication between two IP devices is normally only possible via the respective IP address of the IP device. That means that if an IP device sends information to another IP device, the destination address is always the IP address of the recipient. In the case of KNXNet IP routing, the network structure which was pre-assigned by IP and subnet address is removed by using the multicast IP. So, in the case of KNXNet IP routing, the network structure which was pre-assigned by IP and subnet address is removed by using the multicast IP. If two networks should now be linked together via the KNX multicast IP, it should be ensured that intermediate network router also let the multicast IP through. By default, a network router will first block all multicast addresses so that no attack can be carried out externally. This also applies to newer network switches. Preset filter functions can prevent the multicast IP from being let through. The point is increasing the usage of the IP router will increase the safety in our network, and you should consider that. Of course, it increase our price and cost of the project, but it also increase the safety. And nowadays we have the secure IP router or IP interface that works much better. Interesting. Apart from the KNX IP interface and KNX IP router, nowadays we have the devices in the KNX directly with IP interface. Okay, for example, the switch actuator input output from the Wenzel company, Germany, provide us the direct KNX over IP. Yeah, and also another important thing is using the KNX IP interface based on the KNX Secure. So the data is coded and encoded and nobody can penetrate the system. Okay, so from now on it is highly advisable from the KNX Association to use the KNX IP interface based on KNX Secure. Of course it's a bit more expensive, like more 30%, 40% more nowadays, but it provides us a secure and nobody can listen to the bus, nobody can penetrate or hack it. For IP interface, always you can go to the company Wenzel, Germany, you can go to the company Topco, Germany, and yeah, that's it. You can inquire more information about those companies' website. It's so nice. Thank you so much for listening to me. I hope you learned something, and please let me know if you have any question. Let's see you in the next chapters.